Okay, yeah. So it's our pleasure to have Egypt GP of Vela Partners, the world first quant VC. Rick and Yuhang from Oxford, they are PhD in RL and OAI. So they'll talk about how to evaluate startup founders with AI method, especially refolding method. So this event is organized by DAI Institute and with the very helpful co-host Toronto DAO. The founder Samir Azizi, I think he's here or not, but anyway, yeah, he's very helpful. So thanks for them to co-host this. So yeah, without further ado, let's welcome the speakers. Yeah, thank you.
Thank you, Yuxi. Thank you for hosting us in this fun event. We love, technical and research conversations, and our team, Oxford Research, part of like Oxford Research team, Rick and Yuhang are here as well. Rick, thank you very much for joining from China at a really late time. I think it's like 12, not 11 p.m., I think 12, right? Quite late. Thank you very much for joining really late. So what we are gonna do is that like in the first 10 minutes, I'm just gonna give context of like Vela, why we do this research. Like what is a VC firm in the world? Like would do like research. They shouldn't VC firms be investing? What are they doing? So let me give that context like in this meeting. But at a high level, we do one thing and one thing really well. Like we find outliers earliest. These are unicorns, earliest with the highest precision. And we want to find them when numbers are not present, when there are no revenues or nothing. Like how do we actually make investment decisions and do it in a scientific and quantitative way? So that's what a quant VC is, and Vela is a leading quant VC basically that initiated this asset class. So I'll provide like who we are, why we started Vela, a little bit of performance and vision that we have. So we have like fundamentally like what we do is like we turn this art of investing in early stage into science. Typically what people do is like they use their intuition. I like this idea. This person is great. Let me, invest in this company. So there's like bunch of like, intuition driven pattern matching, expert, decision making. We convert that into science basically. So we are one of the expert, AI funds that actually started in 2017 with a strong skin in the game. We have about 45 to 50 million dollar assets under management, top decile performance that we have in our, funds. Second, like we have AI network, top AI network from Google and Oxford. We really focus on those like networks to be able to, one, invest in great talent and also attract top talent as well. Like Rick and Yuhang, basically from Oxford, is part of our team. And we have an award-winning research program with the University of Oxford as well. For anyone that is researcher as well, we run research internship programs like every quarter, and about like 10 to 15 people join to those like program. It's kind of a research sprint or hackathon, and from those hackathons and sprints, great ideas, research papers come out. Rick and Yuhang are one of those like outlier people that came up with outlier projects. And VC Bench is absolutely one of them that Rick is gonna basically present. So what we do, the third thing is that like besides like investing and making sure that we have strong network, we built basically back-tested and cross-validated AI models and research so that we can deliver top returns to our investors. So that's like the core of the business model. We want to basically invest in outlier startups. We want to accelerate innovation. We want to deliver capital to the right people that is going to change the world as fast as possible. And we need to, of course, like create a profitable business. So we need to pick the right, basically, entrepreneurs to be able to do that. So the fund is forecasting 10x return. We have like bunch of patents that we have filed. We have a lot of papers as well that we have published, a lot of open source that you can actually go and check out. Some of our papers are published in IEEE, NeurIPS, and a bunch of other places. We won Best Poster Award in NeurIPS as well. VC bench that Rick is gonna talk about got super viral, like 1 million impressions in Twitter, got featured in Financial Times, lots of references, as well as like Rick is gonna present that in London, I think, in a conference in this June or July, basically. That was accepted in an academic conference in this summer. So what we do is like, what is this like? What is the business problem? What is the exact problem? So VC is about like sourcing and accessing relatively few outliers. It's basically math and statistics. There are 40,000 companies that get created every year, and only 0.2% become an outlier. So it's a really hard problem to solve. So what we did was like we looked into humans, how humans are performing. So if you look into humans, indexing strategy, if you randomly invest, is 0.2%. If you invest in a company that raised some money, like $2 million, that indexing strategy is about 1.9%. Y Combinator, which is the world's top accelerator, is 3.2%. So one out of 30 investments become an outlier. Top VCs, tier one VCs, is 5.6%. So one out of 16, more or less, become an outlier. So when we looked into these numbers, we were like, I mean, it's pretty cool that these businesses actually create profitable businesses with these low numbers. But we thought that machine should be able to do a better job. They are still really, really low. So we thought that this is a optimization problem. Like most of these like investors hang out in the local maxima here in red boxes, and we want to find the global maxima. So that's like fundamentally what we are trying to solve. And typically, how VCs operate is like they have heuristics, expert heuristics. If it is a repeat entrepreneur, invest. If it is a, Stanford, Oxford, Princeton PhD, invest. If it is a Y Combinator hot company, invest. So these are like some of the typical heuristics of a VC in a superbly simplified way here. But once we did advanced analytics applied to historical data, we found really interesting things that people think is important, but actually it doesn't matter. So child entrepreneurship, people talk about in podcasts. It doesn't matter. If there are like people that want to be an entrepreneur in this call and they hear in podcasts, oh, when I was a child, I was an entrepreneur. And if if you are not an entrepreneur in your childhood, it's okay. It doesn't matter. Speaking many languages doesn't matter. I wish it does. Probably in this call, everyone speaks multi-language, but it doesn't matter in entrepreneurial success. Having a master's degree has zero influence. Joining an accelerator is negative. Repeat entrepreneurship is not always positive. So there's a lot of of these insights. Once we realized these insights, we were like, wow, actually, like many things that people think that it's important, it's not that important. So people are putting a lot of emphasis on things that don't matter. So we were intrigued by that, and we decided to build a business around it. So we looked into the VC investment process. And the investment process is like pretty manual, like how stock picking looks like. You go to events, receive referrals from other investors, you meet with the team, you get data room, you analyze the market, you assess founder idea fit, product market fit, you evaluate team synergies, then you build an investment thesis. So it's very manual. So it's unstructured input, incomplete data, it's intuition based, and there's no math. What we figured out, and Yuhang is gonna talk about it, we figured out the rules of the VC game, like reinforcement learning algorithms, learning how to play games, right? And Yuhang is gonna talk about when we actually look for information, when to stop, exactly like playing in the game. So again, we only do one thing and strive to be the best at it. We source earliest and pick with the highest precision. And all the management fees that we get is going for R&D. not like events, not like, posts or things like that, lunches, expensive dinners or offices. We don't do those things. We invest in engineering. We invest in research. That's everything that we do basically in the firm. So we quantify decisions when numbers are not present. That's like the beachhead use case for us. And this is how the performance looks like. Performance is that like, as I showed you guys, like Y Combinator is at 3.2%, Tier 1 VCs are at 5.6, and our performance is 10x this index is like 19% to 38%. So many of the methodologies here are published. You can take a look. They are peer reviewed as well. And Yuhang is going to talk about those as well. One of those. And the vision and the direction that we have is like, we are humans basically investing, but the goal is to actually be an autonomous VC, exactly like a bank. If you are able to get a mortgage from a bank to get a house, buy a house, we want to do it for entrepreneurship. Like if you want to start a company, you should be able to know that whether you can get X amount, $100,000 or $1 million, at what rate, what's the valuation. You should know this like in a few minutes by sharing your background, basically. That's what you do with mortgage. You share your income level, you share whatever you have, like in terms of like to the bank, and they get back to you within minutes what's the mortgage rate that you would get, basically. So it's credit score, it's called in the United States. So we want to do that the same thing for entrepreneurship. So we have like autonomous digital employee. We call it AI partner. So it does like all the things that we do, like at Vela. You can go to Vela.partners to experience the magic, to use the VC agent that we have. It has super analyst powers. Like it's better than me. Like I'm quite surprised by that. Like, it's better than my partner. It's better than any basically human analyst that we know. And it also has a configurable and transparent brain, basically. So it is like it can mimic how you think or improve that. So that's sort of like the vision that we have, and now like what Rick is gonna present is VC Bench. So VC Bench is the first standardized VC data set in which we compare humans and large language models. And then that standardized data set is used for Yuhang's model, which is number one, basically in that data set. So Rick is gonna talk about how machines surpassed, humans, basically. So, and he will talk about how he applied that methodology as well. So, Rick, why don't you take over?
Yeah, okay.
Yeah, thank you. Huh.
Okay, yeah. So thank you for the introduction here. And I will be presenting on VC Bench, tell you exactly what it is and what were the motivations going into the project, as well as what we managed to obtain out of the project. So as for why we did it, so over the last couple of years, in this new age of AI development, we can see a lot of new benchmarks emerging, which are specifically tailored for LLMs. So examples include arcAGI focusing on general intelligence, and also SWE bench for software engineering. But there's no real equivalent benchmarks in venture capital. And this is, I think, very curious because venture capital is really an interesting and meaningful testing ground for AI model development. So as Ian highlighted, it's a really challenging problem to try to predict the success of early stage startups. So we took on this challenge of constructing the first standardized and anonymized benchmark data set. And in this project, we focused on predictions based on founder profiles only. And this was down to mainly two motivations. So firstly, we found out that in practice, founder identities are actually the most important contributing factor to startup success. And also, secondly, when you look at early stage startups, usually you don't have much information other than founder profiles themselves. But to give you an idea of what we had in mind when we went into the project, and also our current progress on tracking different model performances, this is the leaderboard we are currently maintaining on vcbench.com. So here you can see two different axes of evaluation metrics. We have precision and F0.5 score, which I'll elaborate on later. But basically, you want models to be as high up and to the right as possible. F0.5 is actually our primary metric. So here you can see currently the leaderboard top is verifiable reinforcement learning, which Yuhang will tell you about it later. But here you can see three tiers of performances. We have the human baselines, and then vanilla LLMs can already beat the human baselines. And then on top of this, we have this third tier of performance where we have specifically designed systems. Some were developed by ourselves, and others developed by independent researchers. But these usually use some kind of hybrid method where you combine traditional machine learning methods with this new superpower of LLM reasoning. But as you can see, these kind of methods are working very well on the data set. So let's think about what are the challenges you would face if you would like to construct such a data set. So firstly, we have all kinds of format irregularities. So for example, if you are retrieving the education record of some founder, different people have different ways of calling the same thing. And we really want to standardize these kind of differences. And sometimes maybe entirely fields are just empty. And these two irregularity issues mainly come from the fact that in data in the context of venture capital is highly unstructured. And also a lot of them, for example, LinkedIn data come from user inputs, which is very messy. But the key problem is actually this next one, which is data contamination, which is a well-known problem in LLM evaluation, which is that LLMs can cheat on historical data. So if you ask it to try to predict the success of some founder from the past, then what it can do is it can use specific informations like company or institution names or dates or specific funding amounts. And it turns out that any of these could already be enough for LLMs to be identified in the true identity of those founders. And because those founders are from the past, it will have already known whether they were successful or not. And to add salt to injury, successful startups take typically 8 to 12 years to just get there. And this means that you don't have an easy way to bypass data contamination issues because you can't simply refresh your data set. No matter what you try, if you want to get a large number of startup data that has already materialized, then you have to at least go forward a few years back. And that's well before any sort of LLM cutoff dates. So this is really what we are trying to solve. If you want to evaluate models and compare them on a fair basis, then you have to address this issue. Otherwise, your predictions get extremely skewed. So this is the pipeline we designed for addressing these issues. So we start off with the raw JSON founder profiles, usually taken from Crunchbase or LinkedIn. And we first try to combine these sources and hopefully fill in the blanks if there are any. And afterwards, we go through this format standardization and filtering process to clean up the data. And then finally, we have this important step of anonymization and feature preservation. So the idea of feature preservation is for anonymization, we want to remove specific identifiers like Oxford from these founder profiles. But at the same time, we want to preserve enough information for the prediction models to work on. So here, what we've done is we've replaced these institution names with the QS ranking. So now the LLMs won't be able to use these terms to search up the founder's identity, but they will still have a rough idea of the prestige level of the founder's education background. So we have all kinds of implementations like this in the dataset. So to give you an idea of the final format, this will be an example of a founder profile in VC Bench. So mainly for each founder, we have 4 components. We have industry, education record, job record, and also funding history. But as you can see, everything here is anonymized. You can't find any specific identifiers that LLMs can use as a search up tool. And also specific figures are usually bucketed. So you still know the rough range of those figures for feature preservation, but nothing specific. And I want to elaborate a bit more on how we address this problem of re-identification risk. So what we designed was this anonymization adversarial test, where we specifically ask LLMs to try to re-identify founders before and after our anonymization process. And here's a table summarizing the statistics. So this first column, the rows, you can see different formats that we've experimented with over time during the development of VC Bench. And then these 2 columns, online percent and offline percent, are the proportion of founders that were successfully identified by the LLMs, where in this online percent column, LLMs were additionally given the capability to use web search tools as well. So as you can see in this first row, which is the format we've started with before the anonymization steps, online LLMs were able to identify 77% of the founders. And I think this really highlights the severity of this problem of data contamination, that it has to be addressed in some way. And you can see that over time, we chose different format. And this is when we chose to take off or sometimes add back in some features. And in this process, we always kept track of this re-identification risk. And in doing so, we figured out exactly which features we can include into the data set and which features we should put into bucket in attempt to solve this problem of re-identification risk. So as you can see, for the final data set, we still have some residual risk of re-identification, but especially in the offline case, which was what we were optimizing for, it's already much better than what we started with. Okay, so that's how we constructed the data set. And now I will go through how we evaluated model performances on VC Bench. So after the construction, we took 9 different vanilla LLMs and tested their performance on VC Bench as a baseline result. So this will be just binary classification task. So for each founder, you would predict success or failure. And the primary metric is F0.5 score, which combines precision and recall. But this gives precision a doubled weighting. And this is because in the venture capital setting, we value precision more than recall. But at the same time, we want a reasonable value of recall as well. So F0.5 is really our gold standard. And this goes back to the leaderboard I showed you at the beginning. So as you can see, again, the leaderboard topper is reinforcement learning, which Yuhang will talk about shortly. Okay, so to summarize, VC Bench was the first standardized and anonymized benchmark for founder success predictions in venture capital. It enables a fair testing ground for model evaluations and comparison. And we really had to address the issue of data contamination to be able to get these kind of conclusions. And finally, it encourages community engagement through the public leaderboard. So we really hope that by having this leaderboard, we will drive forward the development of AI models in venture capital. And it's also interesting to see how good the models are performing compared to the human baselines. Okay, so to conclude, I would just like to mention our current direction. So following some feedback on our research on VC Bench, we are now looking at forward-looking predictions. So instead of taking startups from the past, we take startups from today and try to ask questions such as, will this seed company raise Series A in 2 months' time, for example? And the advantages of this approach would be it will bypass data contamination issues entirely because you're looking into the future. And also it encourages model variety because you're free to gather whatever information you would need for prediction tasks. So this is going to be more challenging because as I highlighted, startup success materializes over long periods. So to be able to build up this sort of base of prediction tasks, we are going to need a bit of time. But our hope is that we are going to build a gamified arena where people in the community can input their predictions continuously. And then over time, we can build up a forward prediction benchmark for AI models as well. Okay, so now I'll hand over to Yuhang to talk about reinforcement learning. I would like to just highlight all the people who's been contributing to this project as well. Yeah, thank you.
Okay. Thank you, Rick.
Can you see my screen?
We can see your screen, Yuhang. Maybe a little bit microphone issue. Can you, let's see, like.
So how about now? Like
I
my
think
voice.
it's better. Yeah, I think it's better. I think it's better. Yeah.
I need to like turn up my volume. So yeah. Okay. So yeah, thank you for Rick and AJ for their comprehensive introduction. And today I'm going to present our work, which is our first try on the reinforcement learning. That is, we want to develop an agent to learn what to ask and when to stop. Yeah. So our work starts from a very simple point: is that in venture capital, the information is not free. Before making an investment decision, investors need to collect many different kinds of founder information. They may read a profile, check job history, ask for reference or run background checks, and every step takes time, money, and human effort. So the real problem is not only how to predict the success or not of the founder. The real problem is that how to decide what to ask next and when to stop asking. So this is the main idea of this project. Yeah. Okay, so let me start with the motivation. That is why the current static prediction is not enough. We know that most supervised learning models for the founder prediction make a very strong assumption. They assume that all founder features are already available at prediction time, and they treat the input as complete and free. But in the real venture capital, as I said, the information has a cost. So collecting more data is never free. And at the same time, not all founders need the same due diligence path. For example, if there is a founder with very rich experience, so maybe we can just use very little information to decide he can be success. Or for a founder with like heavy technical background, we need require a different type of evaluation. So that means that the best questions based on the founders. That means we need to generate dynamic information acquisition process depends on each founder. And also there is another important point is that the risks in our due diligence are not symmetric. For example, if we found a founder who later fails, that creates direct financial loss. But if we reject a founder who later succeeds, that only creates the opportunity loss. So the one is financial loss, one is opportunity loss. It is very obvious that the two risks are totally imbalanced. So our task is not just how to predict a founder can succeed or not. A better formulation of this is that what information should we acquire next, and when have we seen enough information to make a decision. And once we ask the question in this way, the problem becomes sequential, causal, and adaptive. Yeah. So based on that motivation, we model the task as a bell curve decision process. In our setting, founder information is divided into 5 query fields, but actually in the real world, the queryable fields could be much larger. But in our experience, we only use such 5 queryable fields. There are educations, job roles, executive experience, their industry, and depth. The depth is actually some additional information to describe the background of this founder. And each field can be acquired independently. The state at time t contains the information we have already queried for the current founder. The fields that we have not queried yet remain masked. So the state is always partial. The action space is very simple. It's just at each step we can take 5 different actions to get 5 different part of background, and also we have one more action that is a stop action, and our agent will choose the stop action if he thinks that it is very confident to make the final decision. The transition is straightforward. That is, if the agent creates a field, and that field is will be added to the current state, and if the agent chooses stop, the current terminal state will be sent to the final decision model, and which is a classifier here, and we can get the terminal reward depends on the prediction result. Yeah. So the reward design here reflects the real cost structure. For query action, the agent only receives a cost penalty. That means we don't want acquire too much information. And when the agent chooses stop, it receives a terminal reward. This terminal reward depends on the final decision outcome, such as true positive, false positive, true negative, or false negative. And we can see that from the bottom, the false positive is actually that we found a founder which will be fail, and the false negative is that we missed a potential winner, and these two reward reflects the 2 risks we have introduced before. So, for example, in the real world settings, we can let the FP reward be -20, that means we will give a very serious penalty if we choose a fail founder, and we can just give the reward of false negative as a -2 because we don't fail to miss some winners. Okay, so now although the MDP formulation looks very nature, but it creates a difficult learning problem. The first challenge is the sparse and delayed reward. During the query steps, the agent only sees a small negative cost, that is the step penalty. The rewards that really reflect the decision quality only arrives when the agent chooses stop. This means that the early actions cannot get direct feedback. And the second challenge is a high variance because we only have 4 types of the terminal reward. That means I cannot get continuous reward from the environment. So our reward has high variance. And the third challenge is the class imbalance because as Rick introduced in our VC benchmark, only about 9% of founders could succeed. And because this imbalance, a standard reinforcement learning method can collapse to a majority strategy. For example, it may learn to reject almost everyone because that looks safer under such sparse reward. So if we directly apply a standard reinforcement learning method such as PPO, the training becomes unstable and it struggles to explore useful long-term strategies. This is why we need a method that can estimate future value before the terminal reward becomes available. Okay, so our first key idea is the Monte Carlo rollout for the non-myopic action evaluation. The difference between myopic and non-myopic decision making is very important here. A myopic method only asks which action looks best right now, but in our problem, the best action may not give an immediate benefit. Just as as Egypt said, the heuristic rule may be not correct. That means we cannot think the founder could success just because he has a high degree or he worked in a large company. So instead of evaluating an action only by local information, we estimate its long-term return. The process works like this. Yeah. So at a given state, we consider one candidate query action. For example, here we query the executive experience. We first force that action, and then from the next action, we simulate the rest of the trajectory by following our current policy network pi until stop. And we repeat this for many times so we can get the average of the returns across these simulated trajectories. And the average return is actually the QSA here, which is the state action value function. We do this for every candidate query action. In this way, each action is judged by the quantity of the full feature trajectory, not just by its local effect. So this is important because some information fields only become useful when combined with other fields later, and the rollout helps the policy to capture that kind of long-range interaction. Our second key idea is the dual scale policy for stopping and querying. Once we have all QSA, that is all the state action value, the natural idea is to normalize them into a vector and treat that vector as a locally optimal policy at the current state. In other words, the rollout values already tell us which actions look better or worse from this state. However, not all actions should be normalized in the same way. For query actions, the question is relative. Among the remaining fields, which one is the most useful to ask? Here we only need to compare the query actions with each other, so a softmax or their rollout values is appropriate. The stop action is totally different. It doesn't ask which field is better than another field. It asks that whether the current information is already enough to make a final decision. This is an absolute uh, confidence judgment, not a relative ranking. So we model stop separately with a sigmoid applied to its own rollout value. And finally, we will combine the query distribution and the stop probability and renormalize them into one final policy. And we call this policy a teacher policy pi star. Okay. Now I will introduce the full model and our training strategies. The first component is our policy network. This is a MLP over the current partial state. It outputs a distribution over the 5 query actions and the stop action. Its role is to decide what to ask next and when to stop. The second component is the classifier. It's our final decision model, and this is also a MLP, but it operates on the terminal state. Once the policy stops, the classifier predicts the founder success probability from the information collected so far. Because the data set is imbalanced, we choose the classification threshold instead of treating the output as a calibrated probability. The key training idea is supervise the policy distillation from rollout improved targets. At a given state, we first run rollout to estimate action values, then we apply the dual scale design to convert those values into a teacher policy. After that, we train the policy network to match their teacher distribution using cross-atrophy laws. This is more stable than the policy gradient training. Under sparse terminal reward and theory imbalance, policy gradient methods such as PPO are much more likely to collapse. At the same time, we train the classifier separately on the terminal states collected during rollout. So the policy learns how to get the information, while the classifier learns how to make the final prediction from the observed information. The two-part design gave us a stable training pipeline for a difficult sequential problem. We also add an LLM supervisor here to stabilize the early exploration of our reinforcement method. The LLM is only triggered when the current policy is uncertain. In practice, that means that the gap between the top 1 and top 2 action is very small. And when that happens, we create a short summary of the information we have already observed and ask the LLM to suggest one next query action. And we don't force the model to follow that suggestion. Instead, we only apply a small bias to the recommendation action. So this will only slightly increase its probability, but it doesn't override the length policy. And what effect does this could have? The LLM supervisor makes the exploration smoother in the early stage of training. Without this guidance, the policy may collapse too quickly to a low entropy behavior. But with the LLM supervisor, the entropy decreases more smoothly, and the policy keeps updating for longer. So this slide shows our final performance with some ablation experiments. The first, we can see that the standard reinforcement method PPO totally failed in our sparse and high relevance reward tasks. And the myopic reinforcement could work, uh, but the performance is not very good. We add a neural network here as a baseline because actually our final prediction model that is the classifier is also a neural network, and we use it as a baseline to show that our reinforcement method save much more save much more information, but with higher performance, with higher 5.5 score. Yeah. You can see that our final full model could save almost half information, but get a higher performance than the full information neural network. Yeah. So this slide show several example decision paths. A clear pattern appears, that is, the model often starts with education and role. So that means these fields provide a structured early signal and help the policy build an initial belief about the founder. After that, the path starts to diverge. For example, for the positive cases, the policy often explores deeper professional signals such as executive experience, industry, and depth. And in some examples, it needs a full picture before it's willing to commit. For example, the first example, we use all the information to get the final result. Yeah. So our agent makes the system interpretable, and for each final decision, we can show what information was cleared, in what order, and at what point the policy decided to stop. Yeah. To conclude, I want to leave you these four messages. The first is that the founder evaluation method, the founder evaluation shouldn't be reviewed only as a static prediction problem. It is better understood as an adaptive information acquisition problem. The second is the main technical challenge is the sparse terminal reward, because use for task feedback only appears at stop, so the naive reinforcement learning fails. And the Monte Carlo rollout helps solve this by estimating long-term action value. Third, stopping should be treated differently from querying, because querying is a relative comparison, while stopping is an absolute confidence judgment. Our dual scale policy separates these two roles and improves the stopping behavior. The fourth is the framework is both efficient and interpretable. It reaches a strong benchmark performance while using only about half of the available information. At the same time, it produces explicit and instance-dependent decision paths. So the main contribution of this work is a framework that learns what to ask and when it has observed enough information. Yeah, that's all of my introduction. Thank you very much for listening.
Yeah. Thanks a lot for indeed, Rick and Yuhang for the wonderful talk. Are there some questions from the audience? Maybe let me ask first. So are there some takeaways for VCs, for founders, based on your study, based on your VC benchmark, and also the leaderboard, lots of those experiments? Are there takeaways for VCs, for founders?
Yeah. So let me jump in. So the takeaway is that, like, Yuhang, first of all, like, the first takeaway with Rick is that with VC bench is that, like, machines are better than humans in decision making. So we gotta use machines as much as possible, in our life. So they are like a great decision support system. That's takeaway number one. Number two, for like Yuhang's, contribution is like superbly significant for VCs, particularly that like VC process is about basically doing due diligence, right? Like it's not like you get the full information when you evaluate a startup. Like you don't know the co-founders sometimes, or you don't know their background, or you don't have enough revenue information. So you are operating in an incomplete environment continuously. So you can't apply these neural network static prediction models in a real world scenario because you don't have the full data. So that's why, like, gathering new information is difficult and challenging and costly because you may need to do entity enrichment. For example, figuring out someone's background, you may need to go to LinkedIn to get that data. You may need to use another paid providers like data. So it's very important to, Yuhang's contribution is to actually, building a model that is actually reflects the real world. Like it's really the real world that like, that when, like, within a minute, you may say, I reject, or within like 1 hour after doing lots of analysis, you might say, I accept. So it really reflects like the real world. I think it's a gigantic contribution to the field. So that's sort of the takeaway for VCs. Like, look into Yuhang's model, that's like real world. For founders, like, I think it's about, from the models and stuff, like it's about basically the takeaways, like, if you're an outlier person all your life, like the fundamental is about being an outlier. If you did like great things before, it's likely that you will continue to do great things. So it's the main takeaway is that, right? Like in the models, if you have done great things, you'll continue to do great things somehow. The probability is higher, basically.
Yeah, that's great. Yeah, other questions from audience. Feel free to open your mic to discuss. Otherwise, yeah, I'm thinking whether yeah, I think in the VC bunch you do a normalization, a yeah, a nominalization. So I guess whether that's a double-edged sword. I mean, uh, so usually, when we see assess founders, they know the founder's name, they know all the background, and they try to find more information, on the internet from other people or something. But for your model, maybe you want to anonymize those. So is that a good thing or not? And maybe a related thing is, um, it seems you are based on the founder's profile, but actually there may be other things. For example, are there some competitors in this field, right? For example, if there are many competitors, or if there are only a few, and how about the economic cycle? For example, currently the AI is so hot, so lots of people want to invest in AI, but sometimes maybe AI winter. So are there these factors? Yeah, what do you think?
Uh, yeah, you actually let me jump in. I think like, my mind is kind of like maybe all of us have become like large language models. I'm filling the gaps. I think I'm filling because there's like an internet connectivity issue. So what you're asking is like, does like the founder background sufficient for like prediction? Aren't there like, idea? Aren't there like market, competition? Aren't these things important? Sort of a thing. Yes, they are important, but at inception, early stage investing, the most important thing is the team and the founder. So the weight of the founder entity is 80% of the prediction. 20% is like time, timing as well as like competition, market, but they are important but less important. So the reason why we picked like in VC bench and all other things, the founder entity is like because of its like gigantic weight in the prediction. and its importance. So other things are also important as well, but like less important. So that's the reason why we did that. But like we will in other models that we have, like that are like that we have proprietary in-house, like at Vela, we look into all those basically signals. But for VC bench and stuff, like we did it because like it's just like a highest priority entity, and it was like a really difficult work to basically do that by itself. So we had to divide and conquer rather than doing a lot of different things. So that's sort of like the thought process. And guys, like we will have, I think, let us know if you have any questions. I'll have to jump to the meeting. Maybe you, Hank, like if maybe you can stay for like some time, because like Rick, maybe you and I can jump to the other meeting that we have, like which is like our month. Feel free to send those questions to us. This is like eat@vela.partners or benchmark@vela.partners. If you send benchmark@vela.partners, we would respond all to your, everyone receives it basically from the
If you
Oxford
don't
team.
mind, I'll put it on the event page on the website.
Perfect.
Yeah. Okay. Yeah.
Um,
Thanks a lot for this. Maybe we'll keep Yuhang for a little while and
yes.
get a
Okay.
couple maybe technical questions. Yeah. Thank you. Thanks a lot. Yeah.
See you guys.
Thank you very
Cheers.
much,
Cheers.
Chi.
Yeah.
Thank you very much.
Uh, so Yuhang is still here, right? Okay. Yeah, maybe one question, maybe that should be to Rick, but to Rick, maybe you're also okay. So I wonder, should it be a classification question or it's a regression question? I mean, you know, either we want to make it a binary or there's a degree of success or degree of failures. So do you think about this? Yeah, what do you think? Is binary classification the best uh, definition of the problem or not?
Um,
Open
so
question.
I don't know because like I just joined Vela
Okay.
for about 2 months, so
No,
actually I don't
no.
know
I mean,
exactly how
feel
the
free to uh, talk about it, right? Either the binary, it's basically a it's a machine learning or AI problem, right? So whether this we want to assess the founder's success or not. So should we treat it as a just binary, fail or success, or we have a degree, right? Degree. So it's a regression, right? Different degrees of success, different degrees of failures. Yeah, for example, some grow to like Google or those big companies. Some just maybe success, but little bit success. So it's still very different, right?
yeah. I totally agree with you because in my current research, actually, instead of just predict the binary result, I predict the potential funding a company could raise in the future. So that means we jump outside from the classifier, because actually in the reinforcement learning, as I introduced in the slides, actually the classifier will bring high variance reward, but if our final decision model is a regression model, actually we can get continuous reward, and that is more. It can give more potential for us to train it with the positive gradient methods. So yeah, personally, I think it may be better for us to reformulate the weighted problem as a like more like a regression problem, or maybe also success or fail problem, but as you said, with many degrees. Yeah, I think maybe it is our next step in the future.
Okay. Yeah. And
So I have a question,
okay, feel free.
if I may.
Yeah.
Thank you. Yeah. So I understand it. I've done quite a bit of investing as well. I think team is definitely the most important factor in getting funding because ideas you can pivot, but the team, the work ethic and everything background, it's very important. Now, the use of AI model to determine, whether or not the team's going to be successful. If that is the case, and then you look at all the current trend where most of the AI, a lot of AI companies trying to replace their, you know, uh, early employees as using bots or OpenClaw, whatever, right? Agents. Now, those agents, their qualifications kind of it's all man-made, right? You can shape it however you want. So have you tried to see if you can sort of using your model to evaluate how, because this is where the future is going, right? If you have the entire team mainly made up of agents. I think people saying that it's a zero employee of like unicorns or something like that. So have you thought about, because those data are a lot more available and also it's more adjustable depending on how you use, let's just say Claude code to adjust the prompt or something. Is it possible that this is also applicable to agents?
Mm, yeah, it's a good question that actually uh, my perspective is that the machine learning models agents uh, could substitute uh, maybe most of the works in the due diligence in venture capital, but it still need human help. Actually, we have many methods that is human in the loop or expert in the loop because we cannot make sure that our machine learning model could handle different kinds of situation. For example, actually the real maybe the real startup the real the real evaluation of the startup may related to even uh, politics uh, or something like very hard to quantities from the market. So my perspective is that it's hard for us to construct a totally agents team do the uh, due diligence.
So probably for VCs, people are still very important. Right? I mean,
Yeah.
humans
Yeah. So
expertise. As
so
for as
that is so that is why we want to add LM supervisor in the loop because I cannot get an expert. So when the algorithm is confusing, uh, I need something to predict, maybe a red correction to predict some slash signal to guidance the algorithm to be trained. Yeah, so I think at least the expert in the loop or human in the loop is better than pure machine learning models.
Well, I totally understand. In general, I also agree that, humans are way better, right? But then the some of the, I'm sorry, I'm late to this thing because I somehow I forgot. But some of the characteristics of like the most, the important characteristics of founders, for example, like, working very dedicated, long hours, nonstop. Those those can just be maximized by agents, right? The agent who works 24/7, never stops. And also the positive attitude, for example, like never uh, deterred by some kind of failure. Because if you look at most of the agent, they're so positive. They're always trying to please you or do something. So that is the question that I have, is that for a lot of parameters, or for the qualities that you're looking for in in the population of the founders who are destined to be successful CEOs or leaders in the future, those are already made, like, to the extreme, made into an agent. And how do you counter that? Because no matter what, you can't find a human being that can work as hard, or you can't find a human being that can suppress all their emotions like in a machine. So that's a question that I have, because most of the time VCs are looking for like the 10xer. The 10xers are these, like what your partner was saying. I couldn't remember his name, but he said it's an outlier, right? Because most of the agents are made very, very extreme. There's like the outlier of the outlier. It's like long, long, long tail. So if the model actually works, then I think that it at least warrants the question to see if this model can be it is applicable to certain features of the agents that's being produced. Because believe it or not, or whether or not we like it, the trend is going to be the agents are going to be replacing employees, and even replacing the rock star employees, right? So I think in order for your model to be appreciated more, maybe you can kind of pivot to that direction a little bit. That's at least just my 2 cents.
Yeah. I think I totally agree with that. Uh, Especially like for some data set collecting tasks, or like just deal with data, or with some repetitive tasks, the agent could definitely work more efficiency than with more efficiency than the human beings. Uh, yes, but the one drawback is that, of course, the model can only capture the features from the data, so it can only learn that very classical success or classical fail. That means the model could never learn like how to select potential founder who may not so strong. Yeah, it just you said the model can only select the outlier of outlier. So uh, yeah, so I think this is the main drawback of the agents. Even though the agents can work positive, can work with long time, but the model cannot solve such a problem.
Okay, I understand. I think that you're saying that the creativity or the human ingenuity is what makes the founder special. I have to go back and look watch the recording, because I didn't attend most of the seminar. I'm sorry I missed that, but I think that that
Yeah, I will make the video soon.
having waited.
Yeah, and also they have a paper. I think they have two papers already.
Okay, that's great. Hey, you see, if you can pass those along,
Yeah, I will do that shortly. Yeah, yeah,
that would be great. Thank you so much. Yeah, this is very interesting.
yeah, yeah. That's great. Yeah. Other more questions? Yeah, we delayed a little bit. Maybe, yeah, maybe I think that's pretty good. Yes, thanks a lot for Yuhang, and also for Ijit and Rick for the wonderful talk. Yes. Yeah. So I will make the video available soon. So yeah, thanks a lot for this wonderful talk. Yeah, thank you.
Yeah, thank you, Yushi, for your host. Thank you so much.
Yeah, thank you.
Thank you.
Yeah, thank you. Bye.